Hi guys, happy Wednesday. I hope you're all doing well, and we're going to get started. This week is very short. You do have to take notes on this, and the notes are going to be what you post. There's no actual work that you need to do to post to Google Classroom. Also, please make sure that you're always reading the assignment. I'm going to put in some little Easter eggs, some little surprises in the assignments. Make sure you read them carefully before you start the assignment and watching the videos and everything. Okay, so if you go back to the table you wrote the other day on families of functions, I didn't give you these two, but they do show up, so I just want you to quickly write them down. So just pause this, add those. Cubic function looks like that. Cube root function looks like that. Great. Okay, so now we're going to take some notes on this. The first is on polynomial functions. So these are similar to like quadratic functions in that there's different forms. There's the standard form, okay, and the factored form. Standard form we've been doing a lot of, right? And it's written out from the highest exponent down, okay, to the constant, the number with no variable at the end. The number at the end is the y-intercept. So when it's in standard form, you can identify the y-intercept. Make sure you write that and draw an arrow to the 8 to show that the 8 is the y-intercept. Also, let's note that the a value in this case is negative. That means that the right side of the graph is going to go down. So whatever that graph is, let me erase that, sorry. The right side over here is going down because it's negative. Okay, and then the y-intercept would cross at 8. The next is factored form. So we've got factored form. Notice that they're in parentheses, and there's 3 sets of parentheses, okay? You can find the roots by splitting and solving. So remember when we were solving quadratics, we would factor, split, and solve. Even with master product factoring, we would always be factoring into parentheses and then split and solve. That's how you find the roots, which is where the graph crosses the x-axis. The a value in this case is in front, okay? So you're looking here in front of the parentheses, and that tells us if the right side goes up or down, okay? In this form, you can identify the roots by splitting and solving. So pause, write that down. Okay. Here, we're going to split and solve. So I'm going to do that with you guys. Okay, so notice I took each thing that was in parenthesis, okay, and I wrote it equal to 0. So there was an x plus 1 in parenthesis equals 0, x plus 4 equals 0, x minus 2 equals 0. Now I'm going to solve each one. To get x by itself, I subtract 1 here, and x equals negative 1. Here I subtract 4, x equals negative 4, and here I would add 2, and x equals positive 2. That means that at negative 1, at negative 4, and at 2, that's where the graph would cross the x-axis. Now the next thing I have to look at is the a value that's in front of the parentheses. Since it's negative, I know that my graph is going to go down on the right side. So when I sketch my graph, I know it's going to go down on the right side, and then I can just sketch the rest in like that. And that's how we can sketch a graph and match it to the roots. So you split and solve, and then you look for the roots, and you make sure that they match with the numbers here. Quick note, when the x is positive, okay, the root is the opposite sign. So if it's plus 1 inside here, then the root is negative 1. That's a quick way to match it up. Next week, we're going to learn how to actually factor these more difficult polynomials. So pause, take notes on that. Okay. We're going to just do another one. I'm going to just make a little edit right here. Okay. So we're going to split and solve each one. So I split everywhere that the parentheses touch. I'm going to identify that the a is positive. That's in front of the parentheses, so that means the right side is going to go up. So here I write each thing that's in parentheses equal to 0. negative x minus 3 equals 0. And now I'm going to go through and solve each one. Okay, so here I just have to subtract 5, and x is equal to negative 5. Here I just have to add 1 to both sides, and x is equal to positive 1. Here I add 3 to both sides, but when I bring this down I have negative x equals 3, so now I have to divide by negative 1. And so x is equal to negative 3. So that means that my graph is going to cross at negative 5, that's this one, at positive 1, and at negative 3. Okay, I know that the right side is going to go up because my a was positive. So the right side is going up, and then I can just sketch the rest in like that. Okay. Here, when you take notes, you only have to write one of the examples. You don't have to write both. So I'm going to just quickly go through. The first thing you want to do is identify the roots when you're given a graph to match it with an equation. So I'm going to circle them. Okay, those are my 3 roots. Then I'm going to look at the right side. If the right side of the graph is going up, I know my a is positive. So my equation is going to be, since it's positive, the number in front is going to be positive, or there's positive in front of the parentheses. Since it's a negative 6, my root, it will be x plus 6. Negative 1 is the next root, so it's x plus 1. It's always the opposite sign. Positive 4 is going to be x minus 4. And that's the equation that would match. Let's look at the next one. The right side is going up, so my equation is going to have a positive in front of the parentheses right here. I circle my 2 roots. Since it's negative 5, the equation would be x positive 5, and since it's positive 6, it would be x minus 6. And that's what would match. That's all you have to do to match the equation with the graph. Nice and easy. Okay, just draw one of these examples. You don't have to do both. This is going to be a similar idea, but a little bit different. We circle the 3 places. Notice that one of them is 0. That's going to be important here. So when I write my equation, I look at the right side. It's going up, so it's positive. So it would be positive in front of the parentheses. The first root is negative 4, so I'm going to have x plus 4. The next root is 0. But instead of writing x plus 0, because x plus 0 is really just x, if you simplify that. So we're going to put in the x and we write it in front. That's the important part. And then the last root is positive 3, so that would be x minus 3. So the important thing to notice is that this x in front matches with the root of 0 right there. So you want to write down, when you write that example, when the graph crosses the origin, the equation has an x in front of the parentheses. Okay, and you can just do one example and write that underneath it. I'm going to do a second example as you're writing those notes. So I circle my 2 roots. Again, I have another root that's at 0. That means that, and I look at the right side, it's going up, so it's positive. So it's going to be positive in front, and because it crosses at 0, it's going to be just an x. Okay? Then I have a negative 5 root, and so that's the opposite, would be x plus 5. And that's how that would be written. Okay, let's pause. Let's do the last one together. Okay. We always look at the right side and we circle the roots. Okay. Notice this one has an interesting root. Right here, it doesn't actually cross through, but that's the relative minimum, right? That's where the bottom of the u is. Some people say that it's just kissing the x-axis. When that happens, we actually learned when we did behavior of polynomial functions back when we were in school, which I miss so much, that would be squared. So what do I mean by that? Well, my first root is negative 7, so that would be x plus 7, and it was positive in front of here because the right side was going up. Then my next root, which is that special kissing place, positive 2 would be x minus 2, but then we put a squared here. So when you highlight in your notes, make a connection between those two. If the root just kisses it, doesn't cross through, but just touches it where it's a relative minimum or maximum, that's going to look like this. It could also be written like this. Write both examples down when you take notes because you're going to see both types of examples, okay, in the delta math. So it can just be written out twice or it can be written squared, either. Let's do one last one. Again, you only need one. And then in your notes, write the example and write when the relative minimum or maximum kisses the x-axis, that root is written twice. And I'll do the last example while you're writing that down. So I look at the right side, it's going up. I circle my roots. Okay, the root right here is kissing because that's a relative maximum right there. So it doesn't cross through, but it just touches and then comes back down. Y equals positive because it's going up on the right side. X, since it's negative 8, I write plus 8 squared. And then since it's a positive 1 right here, I write x minus 1. Remember that it can also be written y equals x plus 8 2 times. So that's the place where it's kissing, okay? There are penalties in this delta math, so make sure to look at these things closely because they're going to be exactly like what we just talked about and practiced. Okay. You do not need to write this one down. To sketch a graph for this function, actually I'm going to undo that, because we're going to look at a couple things. The first thing I'm going to look at is the degree right here, okay? I'm going to look at the a value right here. So remember, this is the a, this is the degree, and we just learned when it's in standard form, this is the y-intercept because it's the constant. Okay, now we're going to identify lots of things. So we wrote in our notes last week that the number of turns is 1 less than the degree. So since the degree is 6, this would take 5 turns. So the graph is going to turn 5 times. The y-intercept we just labeled as -2. The a value is negative. That means that it goes down on the right side. And I said you didn't need to write this down. If you want to, you definitely can. It's not a bad thing to have this written down. Odd or even degree. The degree is 6, so that's an even number. An even number means that both ends go in the same direction. Now, we can actually sketch this out. This is not in factored form, so I can't find the roots. So I can't look on the x-axis and find the roots. Can't do that. So instead, I'm going to plot the y-intercept, which is at -2. So I plot that first at -2 on the y-axis. And then I know that the right side is going to be going down, and I know that it's going to make 5 turns. So this is what's going to happen. We can do something like this. It's going to go down on the right side. So that was 1 turn right here, another turn right here, a 3rd turn right here, a 4th turn right here, and a 5th turn right here, and then it's coming down. And let's take a look at that. On the left side and on the right side, they're both going down, and that matches with the fact that it's an even degree. And that's it for this week. Make sure you have good notes and then have fun with the delta math. Bye.